All right, the second type of graph for this unit. So remember, every unit we're going to do two graphs. So this graph, we're going to do the vertex form of a quadratic equation. So over here, you'll see the general form of the vertex form. Um, you'll see that the quadratic has been factored. So what we have here is we've got a couple factors, but they happen to be the same. This is that perfect square binomial we'll talk about. Okay, what we do, well, we know that this is the input of the quadratic. So anytime we mess with the input, we always do the opposite, see the negative, the opposite of what we see. So so no matter what h is, we're going to do the opposite of it, and that h then will be the coordinate, x coordinate of the vertex. So if I look over here, I see that they've got a +3 right here. So what that means is that this vertex then, so the vertex, we look at this is your h, so we do the opposite of what we see, so the x coordinate is -3. Whoops, didn't put a plus sign here. This is supposed to have a plus right here. So then you see plus the k. So plus the k, well, the k is the y coordinate of the vertex. And so it's a plus sign here because remember, vertical transformations, we always do exactly what it says. So see the -6 over here? So we're going to do exactly what this says, and we're going to drop the y down 6. Remember that this guy likes to go through the origin at first because 0 squared is 0. So y equals x squared, the parent function, produces 0, 0 as a critical point. So that's just the straight up transformations we've been doing all semester, where if it's in the input, we do the opposite. If it's outside of it, we do it exactly like it says. So the cool thing here is we already know our vertex. So that's kind of cool. So we have a vertex that's -3, -6. Looks like he's down here. So our vertex down here at -3, -6. The problem is we don't know where to draw this through. Does it cross here, here, here? We don't know where to draw through the y-axis, and we know that that's going to be the initial time. So we need to figure that out. So I could go ahead and put this in standard form, but just like we did last unit with the polynomials and the lead term, all I really care about is the constant at the end, right? So if I do this perfect square binomial, I'm going to get perfect squares on both sides, and that's what I really care about, and then 2 of the inside term. So really, if you see, the only constant's 9, but I had -6 here. So then I know that add those up, I'm going to get a constant term of 3. And that is where I need to go through. So 3, it's going to go up through. Oops, missed, but you'll be able to do a little bit better than my painting skills. And then again, we're back into that. Well, what's the domain, range, and behavior? So it's still a polynomial. So don't miss this part. This is the answer for all polynomials domains. But the range, because quadratics are always even functions, they're always going to have an absolute max or min. And we have to go ahead and label that. We don't get to write the name absolute max or min like we did in the last unit. So now we have to go find it. So then the end behavior, it's an even function, so it can go either way. And when we go either way, this guy wants to shoot up forever. So what's cool about the vertex form is straight up what we call it for. It's the vertex. Man, that's pretty handy. I didn't have to do synthetic division. Didn't have to go find that or the remainder theorem. Didn't have to use the axis of symmetry. But the problem is I don't know what the intercept is right away. I need to go find that. So the reason that we don't write more quadratics like this is not all quadratics can form this nice little binomial here, right? So the problem is this is a rare situation, but man, if we see it, it's pretty quick. We should probably take that hack to speed things up. So cool thing about standard form is it gives me the intercept. I got to go find the vertex. Cool thing about vertex form, it gives me the vertex, but then I got to go find the intercept. So be ready to graph both of these and talk about the range, domain, and end behavior.